Hi, welcome to another pre-calculus mini lecture. Here is two short problems we are going to look at here. Uh, Topic is inverse functions, linear and discrete. Discrete is the first example and linear is the second example. We are asked a set of simple questions. If this is the function g, what is g inverse of 3? Let's understand what this notation for a function implies. This function is given by list. It is simply a table where here is, let's call it input, and let's call the other column output. These are what you usually call x and y. X is the first entry, like 0, and y is the second entry, the output 3. 1 and 4, x is minus 4, 2 and 5, 3 and minus 5. So this g is just this table. For a set of input values, we are given set of output values. With function notation, how do we write this? We say if you assign g to work on a 0, g of 0 is 3. G of 1 is minus 4. G of 2 is 5. G of 3 is minus 5. So, what is the inverse function? Inverse function, when it exists, it's a rule that takes you from this column to this column. This is called G inverse. So G inverse of 3 is 0. G inverse of minus 4 is 1. G inverse of 5 is 2. G inverse of minus 5 is 3. Notice that we should not have any kind of conflict. When we go from this side to that side, it has to be clear where we are ending up at. There should be no conflict. Going backward, same way. For any of these numbers, there has to be only one of the x values. That is what is implied by 1 to 1. Anyway, so G inverse of minus 3, you go through second entry, you see the 3 here, and so the answer is the x value that corresponds to that. Okay, first question was simple. Second question about a linear function. We are given some linear function and we are supposed to find the inverse of it and manipulate that inverse. That's just as simple. So we are given h of x is equal to minus x plus 9 over 5. In the previous lecture, we went through the introduction of what the inverse function is, how to calculate it, and so on. We are practicing that again. In the next lecture, we are also going to look at the same issue with slightly more complicated function. So what do we do now? Most straightforward way of inverting a function, again, inverting the function means instead of going from the first column to the second column, we want to go from second column back to the first. So you ask yourself, if I have a value on the second column, how do I find the corresponding value in the first column? Well, in this numerical example, you just look it up. When it is given by a formula, we have to turn that formula on its head, so to speak. So you write it, y is the output, it's minus x plus 9 over 5. First, find x in terms of y. Well, how do you do that? We want to isolate x. To isolate x, let's get rid of this 5. How do you get rid of 5? Multiply by 5 on both sides. So you get 5y is minus x plus 9. Again, the objective is to isolate x. Let me color x. So we keep our eye on that so that we isolate that. So I want to isolate it. So let's get rid of 9. So it becomes 5y minus 9 is equal to minus x. Again, I just want the x alone. So multiply both sides by minus. So it becomes minus 5y plus 9. So now you have the y, you can figure out the x. Traditionally, what you're given is written on the right hand side, and what you obtain is written on the left hand side. So this formula, even though this is exactly the same thing, we write it as x is equal to minus 5y plus 9. Now at the very last step, we are going to use something that is just traditional, which is the input of a function is taken to be letter x. So what we do at the very end is exchange x and y. X and y, we're just going to change their names. Instead of y we write x, instead of x we write y. Now that is the inverse function of the original function. So what we had at the beginning, let's write h of x. At the beginning we had h of x. You remember we had minus x plus 9 over 5. I forgot already. Minus x plus 9 over 5. What we find here is the inverse of it. H inverse of x is what we got here, minus 5x plus 9. If you look at it for the linear case, this is rather obvious as to what happens. You look at your function, you see that you are adding a 9 to minus x and dividing by 5. Division by 5 is done at the end. Here multiplication by 5 is done at the beginning, and then we have plus 9. Now another question that is asked here is, what is h inverse composed with h of minus 1? Well, the answer to this doesn't really depend on any specification of the problem itself. The combination of a function with its inverse is a so-called identity function. So whatever you start at, you're going to end up at that answer, that number. So here, without any work, I know the answer is minus 1. So we are going to, let's talk about it two ways. One, we are saying if you start from some number and you apply a function to it and get that output, and then you apply the inverse function, well, you're going to go back to what you started with. So combination of a function and its inverse always brings you back to the starting value. If you want to look at it in practice, over there the question was, what is h inverse of? H of minus 1. So that's the question, what's the h inverse of h of minus 1? So one way to answer this short quick answer is that, well, it's just whatever the original number was, that is what the answer is. It doesn't depend on any details of h. But if you don't believe me, let's try it out. First of all, what is h of minus 1? Okay, so if you want to actually calculate it, we take this number, feed it to the first function h, which means feeding it to this function, so minus 1 plus 9 over 5, so that is 1 plus 9 is 10 over 5, that is 2. Now we take this and we pass it to h inverse. h inverse of 2. So where did 2 come from? 2 came from the output of the first function. Well, what does h inverse do? It's minus 5 times 2 plus 9. Well, that's minus 10 plus 9. That is minus 1. And what we were saying at the beginning, after all this work, all that we recover is what we started with. And what we said is, okay, this always happens. So if you want to do a quick calculation, h inverse of h of anything is just that thing. It works both ways. If you have h of h inverse of any number, let's write a for any, it's just that number. Same way with h inverse of h of, again, any number is just that number. Okay, so that was a short look at the issue of inverse function with respect to discrete functions, which are given by a table, and linear function, which are given by this simple format. Okay, our short lecture comes to an end here. Until the next one, good luck and God bless.